Another box here contains very important concepts in thermochemistry. Energy first of all, and it's the capacity of system for doing work. Work here, we're gonna underline it. It's important. Heat as a shape of energy, and it's abbreviated by Q. Heat when energy of system changes as a result of temperature difference. So the temperature itself, it's the measurement of heat. You are supposed to distinguish between temperature and heat. Heat, it's a shape of energy. Temperature, it's measurement of heat. And it's measured by using three familiar scales. We took it, I think, Fahrenheit, Celsius or centigrade, and finally Kelvin. So that work, it's equal to forces applied over a certain distance. So that force and distance, actually, it's a physics. If we deal with closed system like this, applying a piston, providing external pressure here, so that the pressure going to apply a certain force to make this system compressed. This system, if we suppose, for example, there is a certain reaction in it internally. Suppose A plus B, any kind of reactions. Right now, we are going to measure the heat or the energy of this system, thermodynamics related to those concepts. So that we applied external energy and this system is compressed, like what do you notice here. So after that, remove the external pressure. Let this reaction carried out automatically. This reaction provide internal pressure, internal work, any kind of internal energy causing raising for this level of the seals and its turn over here. So that this work, it's going to be measured by using the weight and the difference of volume here. It's the distance that crossed, so that it's change of volume. Actually, it is deep details. And by avoiding talking about the pressure, as a result, the energy, it's equal to heat in a constant pressure. The question is, how could we measure heat? Heat, if we suppose, heat is the energy of the reaction. And avoiding talking about changes of pressure, directly the energy that's going to be produced or consumed from a certain reaction, it's going to be measured by using calorimeter. Calorimeter, it's an isolated system provided by a thermometer here and electrical current as a force or as a power supply. So that, guys, you will find heat, it's measured or indicated, heat of the system, the reaction internally. It's going to be indicated by the changes of energies, which is changes of energy. It's the heat indicated by thermometer here. And also, guys, abbreviated by Q. You will find that there is direct proportionality between heat and change of temperature. And this proportionality, it's turned to equality by providing or by multiplying by this equation or proportionality by a constant C We call it C, heat capacity. It's like a fingerprint of each material. Each material, it's indicated by its own heat capacity. So that as a result, heat as energy, it's equal to heat capacity times change of temperature. And also, we could deal with it by the molar heat capacity, molar heat capacity. Molar, it means something related to moles, so that we just add number of moles here. Q, it's equal to number of moles times heat capacity times change of heat.